Good afternoon. We're honored to be given the opportunity to go ahead and present here today. My name is Kevin Chung, manager of the DevOps Site Reliability Engineering Group for eCommerce at Under Armour. I'm joined by Stephen Schmidt, our lead site reliability engineer at eCommerce. And I want to also just take the opportunity just for a real quick special thanks to Andy. Within the first hour of us actually landing here in San Francisco, we had our laptop stolen out of a rental car. So it's been a little bit of a rough summit, but Andy has kindly lent his laptop for us to be able to do our presentation. So we'll do our best. So at Under Armour, our mission is to make all athletes better through the relentless, through passion, design, and the relentless pursuit of innovation. And especially these days, we strongly believe that sports really has the power to change the world. Sports can inspire, unite, and even change the world. That's our latest message, brand message that we feel very passionate and very strong about. So specifically with eCommerce, I want to take a moment to talk about how we fit into a little bit of our larger connected fitness organization. And so in 2013, we acquired MyFitnessPal. Later in 2015, we also acquired MapMyFitness and Endomondo. And so as a result, we now sit with the world's largest digital health and fitness community. We have about 200 million users across this portfolio of apps with nearly 100,000 or more new daily downloads of our apps. We see about 7 million workouts that get logged every day on our platform, and 31 million foods logged by our users daily across our platform of apps. Special note for our Californians, at least with our US population, represent about 10% of our overall number of workouts as well as food, so go Californians. Nice job. How does that tie into e-commerce, and specifically with Spinnaker? Well, let me talk a little bit about our e-commerce business, first of all. So it's not only just UnderArmour.com itself. I mean, that's a large portion of our site, which is what we consider our direct-to-consumer side. We also then have our team business, or wholesale, what we call B2B internally. This includes everything from your recreational league teams to soccer moms that are ordering for their teams, all the way up to our collegiate platforms. So if you've got, say, Cal Berkeley, Notre Dame, University of Wisconsin, and in 2019, we're also going to be extending that out to supporting the equipment managers for Major League Baseball. We have that contract for the on-field uniforms. We also now have a shop app, mobile app, UA Shop. Endless Aisle, which is an omni-channel in-store retail app that we have to support. This thing called Armour Box, which is a subscription box service, kind of like a Stitch Fix, but with sports gear. And UA Icon, which is our latest innovation. With all these different properties, it was important that we had to iterate very fast and very quickly. So we needed a system to be able to manage microservices, but also Kubernetes. So brief note about UA Icon. It's the world's first digitally printed customization platform. So literally, you can go ahead, practically upload any sort of artwork you want, and in about 6 weeks, you can wind up with your own custom-made footwear. So actually, while I was here at the conference, I was playing around on my phone. You could, if you wanted to, order your own custom Spinnaker. So I don't know if like Netflix internally or at your organization, if you got like a sports league or something like that, you guys could totally go ahead and upload your own logos and really dominate out on the field. So again, to recap some of our project goals going into Spinnaker. We talk about things like infrastructure as code, mutable infrastructures and artifacts. Being provider agnostic is very important for us. Because we have different properties for service level agreements, we try to go ahead and select different providers as necessary. So we wanted a platform that had a lot of flexibility. You didn't want to be tied into a particular provider. So we use a combination right now of both AWS, GKE. We still have some legacy bare metal on-prem. So we wanted a system that could actually tie all these things together and consistently deploy out to them. The consistency between environments. So at Under Armour, I think in the panel I was in earlier this morning, question came up about like doing different like service or like memory limits on containers. We want everything to be as consistent as possible. A developer environment largely should be the same as our staging or production environments. The only change there is maybe the scaling of those pods. So while in production we may have hundreds of pods serving traffic, we only need a single pod. But the underlying infrastructure itself should be the same instance types, and we need to be able to manage and create those environments, and that's where we leverage Spinnaker. And finally, we wanted things to be developer self-service. Simplify our code release. Our developers are largely responsible for deploying their own code. They're the ones that are on call. We don't really have an operations team in the traditional sense. So these were all the design patterns that we went into, and that's how we landed at Spinnaker. But if we take a step back, we actually developed this tool called UA Deploy. It was a deployer utility for Kubernetes that we wrote in Go. And the reason is that we needed to do some sort of build towards actually having stages in our deployments. So one of the weird things that we actually did, kind of a crazy thought that came up, is that what if we actually took our manifests themselves and embedded them right into the artifact? And that way we could also take things like, so we use Liquibase for doing schema changes. We actually embed Liquibase out of the commit, so at the time it's getting built, we have that dependency to know that those changes to, say, the deployment or to any schema changes are tightly coupled directly in the artifact. We're not having to go to another repository and pull that down. We actually build it in, and then we have a consistent manner that on every deployment, pretty much all of our pipelines are pretty simplistic. We always are running Liquibase as a stage with our deployments, and realistically, we only have even though we have somewhere around 100 artifacts, we have the same base sort of set of deployable objects. Luckily, our platform team works very closely with us, and they define out a clear spec for an API, for a service. So we really don't have a lot of different types of deployments. We have a lot of pipelines, certainly, one pipeline per artifact, but all of our actual sort of styles of artifacts is pretty consistent. So I want to talk a little bit also about our software development workflow. So one of the keys for us in rolling out Spinnaker, I thought, was really thinking about the process. And how do you ensure that whatever you built is what you're actually deploying out to each of your environments? It's the build once, deploy everywhere model. We don't want to introduce any changes. So it's based off of GitHub flow, or the GitHub flow, largely. And so basically what we do is we dynamically actually build out a pipeline off of every pull request. So whenever a developer opens a pull request, we dynamically actually generate a new pipeline to deploy out that artifact. That's what immediately gets deployed out into our staging environment. Only after it's passed through validation, whether it's automated validation or manual validation, at that point, then a developer can actually merge their change in to master. And when they merge it, we then take that artifact and we re-tag it with a unique tag. So where the tag might read PR dash and the git commit, it now just becomes master with that associated git commit. And that's what we actually go ahead and push out to production. So that way we're ensuring that the actual PR that was built is what we are promoting out to production. I also want to mention dynamic environments. We have a separate Spinnaker cluster for our development environments, as well as one that handles all of our staging production pipelines. And again, as I mentioned earlier, thank you, Lars, for Halyard. It's really simplified the ability to go ahead and add in these dynamic environments on the fly. So with that, we'll do a deeper dive into some of our tools, and I bring Stephen up to talk our way through some of the tooling that we've built to support Spinnaker.
Hi everyone, I'm Stephen. So one of the key things for us to get to a point where we felt comfortable with handing over some things to developers is we needed a capability throughout our deployments to run automated tests after we deployed something to a given environment. So we've been working closely with a QE engineering team that we have internally at Under Armour to kind of develop a suite of tests that we can run. So essentially, Kevin mentioned before we had this other tool called UA Deploy, but all it really did was run schema changes if we had them, and then just deploy a Kubernetes manifest. So I think one of the cool things about Spinnaker, and it's been brought up multiple times throughout this conference, is it gives you a lot of capabilities to orchestrate around your deployments. So things that need to happen, ordering, so on and so forth. So one of the things we do is we run the system tests when we go ahead and deploy an artifact. And then this will happen in staging, and if it goes okay, what we can do is then have that artifact get promoted into production after it gets merged, based on the workflow Kevin went over earlier. So we are running pretty much Node.js everywhere for our application stack. So we're using the Ava framework to kind of hit all those API endpoints for the tests we're running. So we have a B2C platform API that we hit. It basically is the end-all be-all for a lot of our other microservices. A lot of different calls come in through that, so it's important that we flesh that out in order to properly validate our B2C application. And our B2C application, it's kind of a monolith, so we will be working on breaking it up, but Kevin mentioned earlier we have a pipeline for every artifact we have, so we probably have about, I want to say 90 to 100 different microservices at this point. And then we also generate other pipelines depending on the different workflows that are going on. I'll go over something later, but we have some internal tooling that allows developers or us on the team to go ahead and generate pipelines and test out changes and things like that in our integration environments. So these are just the other various APIs that are kind of getting tested when the system tests run. I don't know if you want to add anything onto that.
Yeah, I just want to make a quick note that one of the things about using the Ava framework is when we actually set this up, we're able to execute roughly 60 tests in parallel. And on any deployment, it takes only about 30 seconds to run those automated tests. So when we talk about doing fast deployments of pipelines, also, so those tests are actually, it executes a stage in Jenkins that actually runs the tests. And out of Jenkins, we use a plugin then to feed all the results from our system tests into Splunk. So we only have to expose Splunk out to our QE team or our developers to be able to review the results. And then we can do a judgment based off of those system tests to say with confidence whether or not we want to go ahead and deploy this out and push it to production.
We also have an internal tool we kind of use right now. It's pretty rudimentary, honestly. Wrote this a while ago, like I want to say 2016, because we needed a way to quickly update our pipelines. And this kind of ties into some of the other things we're doing with, we'll go over that tool in a second, but we have another tool that won't be lasting much longer given the V2 changes that are coming to the Kubernetes provider, but we needed a stopgap because we had already made a decision internally as a organization that we were using Kubernetes deployments for better or worse, and we were not in a position where we could easily go back in time. So we had to kind of work around those constructs. So this is just a tool for interacting with Gate at a pipeline level, and we have some other rudimentary like cleanup that happens for some of those staging pipelines that get created. This is the other tool that I kind of went over a little bit. So what happens is we can pretty easily create development pipelines. So if you're a developer, your artifact goes through, so we have Jenkins for CI, and what would happen is you'd get an artifact from Jenkins, and then you could pass it into this CLI, and it would generate a pipeline for you. And then you could either grab the JSON or use the Spin CLI tool that we have and upload it into Spinnaker. And then you could go through and test that pipeline and validate that it actually works. So I should probably take a step back. A lot of our developers, they're not going to be making Spinnaker pipeline changes per se. They're going to be making Kubernetes manifest changes. That's what they're familiar with. That's what they know. Maybe we'll get to a point where we have time to train them and they'll be doing more actual Spinnaker pipeline changes. But for the time being, it's mostly just around Kubernetes manifest. So we needed a way to allow them to still do what they do with the Kubernetes manifest, but kind of convert it for them and give them an easy way to validate things in their integration environment. So this is basically just generating an integration pipeline that they would run in one of those team environments that Kevin had mentioned earlier.
Does your does your tool then just convert that manifest into a deploy stage, or does it do anything beyond that?
Yeah, so this tool is very specific, and like I said, it's probably not going to last much longer. This was also written in like 2016. So what it's doing purely is for our deploy stage, it's taking Kubernetes deployment manifest and mapping it to the Spinnaker JSON that we need in order to deploy it.
So you'd mentioned deploy the pipeline and then verify it does what you expect it to do. How do you do that verification?
Currently, so they could, if they're grabbing the actual pipeline, our pipeline template that we have out there, it would run through the same system tests and some of the other things that we do in our staging and production pipelines. Also, our users are fairly savvy with Kubernetes. So if something fails within the actual pipeline, they have access to their Kubernetes cluster, so they can do some debugging at that level, or we have some things going into.
I guess I was wondering how you correlate what the pipeline you fed in was supposed to do with what the expectations are to validate. You know, you say pipeline do X, Y, and Z, and you change it. How does the validation relate back to the pipeline? That's what I was asking.
The validation is mostly around, so we would, the feedback we would get from Spinnaker if the deploy failed, because most of the times what they're doing is just purely Kubernetes manifest related. So we'd expect the pod to probably not start up if they had a bad manifest change, and then they could go in and look at it and tweak it based on the output from Kubernetes.
Okay, thank you.
Mm-hmm. So what we use Artifactory internally for artifact management, and what happens at CI time is an artifact will get generated, and we have a kind of a tool that goes out and pulls to grab. So the tricky thing for us was it's difficult to kind of manage through Artifactory, setting up a polling cycle for every single artifact we have, given how we do some of the Docker tagging. So we had to kind of come up with a different strategy around it. And this basically takes some of our constructs that we use for tagging and goes out and discovers artifacts based on the different areas that they're going into. So for this specific one, it's mostly, this is a integration, this is the integration Spinnaker that we have. So it's running fairly often. So it's grabbing any upstream changes and it's actually updating the pipelines in source control. What also happens for I should step back as well, the K8's pipeline converter, it actually does a MD5 sum on all of the pipelines it's trying to potentially update. So it's not going to update it if nothing's changed. One of the other things we do is we have, we have Jenkins running in Kubernetes as a pod. So it's actually a public set, but so we deploy it with Helm, and basically we're leveraging that to kind of consolidate the Jenkins infrastructure and just run it with inside Kubernetes rather than have a whole bunch of EC2 instances. For our actual CI environment, we're using more of a traditional Jenkins where we we're using the EC2 Spot Fleet plugin to go out and spin up the workers and carry out the builds. But for Spinnaker, we have a kind of like a special worker that we created in order to run Docker within Docker, actually. So some of the tools that we were showing earlier, they're all built within Docker. So we can leverage just running them within those Jenkins workers that we're running within Kubernetes to execute the different things that we need to have done. One of them would be, so we use Akamai as well. So purging the cache after we do a deployment would be a potential stage in the pipeline. So Kevin kind of touched on this. We've kind of moved towards using kops for managing our Kubernetes clusters. So one of the things we were trying to accomplish with the team environment, with the integration environments, was to give teams the capability to have a more self-service kind of philosophy. We're getting there, but the end goal with this is we'd like to see teams to be able to come into Spinnaker and spin up a Kubernetes environment with a pipeline, essentially. We have a lot of the, so we're gonna basically, to do the actual main orchestration, we have a lot of other pipelines that do a lot of the different pieces that allow us to spin up the cluster. One of them is the piece Kevin mentioned earlier around Halyard actually adding the account to Cloud Driver and then going ahead and refreshing Cloud Driver in order to incorporate the account. We also do some secret management within S3. So all that's encrypted in a bucket up in S3. So pulling all that down, getting all that provision for the teams ahead of time, and then having Spinnaker actually go ahead and just deploy all the artifacts into their team environment is something we heavily use Spinnaker for right now. We also have a little terraform in there, not too much. It's basically just, the terraform is really just used for spinning up the static AWS resources that we have, mostly just ELBs, ALBs, and security group related resources as well. And to Kevin's point, we have a very, we try to keep all of our environments very similar. So going from integration to staging, it should look and feel very much the same way and perform just at a different scale. But the underlying way we do it and the underlying infrastructure is mostly the same. And as well as the data sources. So it's pretty important. Each team environment it has its own data backend. There's a slight difference with how we're doing that, but it's, at the end of the day, it's the same data. The implementation is slightly different. We're using pet sets within, stateful sets within Kubernetes to kind of manage those, but that's just to make management a little bit easier, but it's the same data sources.
So what's next for us as far as looking at the future? As I mentioned, we have multiple properties. So GKE is just something that we just started to spin up for our team environments. So naturally getting them to work with Spinnaker in a GKE environment. The reason for that is that our B2B team is much smaller. They don't really have a dedicated DevOps resource, and they just simply want to leave the management over onto Google for their cluster. But some of the other things that we've been playing around with lately, we actually just got back earlier in the year from Google I/O, and so we played around quite a bit with API.ai. So we actually have launched a ChatOps bot that works with API AI with natural language, and seeing about plugging that into Spinnaker in order to do some operations. So far, we have been doing quite a bit with just Kubernetes in general around our cluster health, but seeing if we can actually get some more intelligence there into our pipelines. That's pretty much kind of, at least within our e-commerce business, what we're looking at with leveraging Spinnaker. But as I alluded to earlier on, we also have our connected fitness group. And so how do we get Spinnaker adopted in other parts of Under Armour? That's a big part that we're very interested in. You know, how can we actually take this and then get our connected fitness partners and other parts of Under Armour leveraging this technology that we built? We're all in on the e-commerce side, completely on Kubernetes. Looks like there's some interest from some of our other parts of the business. And if it wasn't made clear, the thing at Under Armour that kind of makes us unique when we're talking about it, certainly other apparel companies, we actually write all of our e-commerce platform, all of our components in-house. We're not leveraging some commercial off-the-shelf platform for e-commerce. It gives us a lot of flexibility. There's no way we could have launched some of those properties like Icon to go forward. And we're also, you know, we borrow quite a bit from sort of the Netflix model. So I think it was in one of the other talks, might have been Adam's talk, about immutable infrastructure and chaos engineering. And so these are all concepts that, you know, Spinnaker handles beautifully. And especially now that we're looking at a lot of the shift that's happening from retail, traditional retail, into e-commerce and other channels, and as we're going to expanding out, certainly in other markets, Latin America, the sites that we launched just recently, like Turkey, South Korea, some of these other sites, we have to look at how can we also manage that infrastructure ideally, again, through multiple cloud providers or even separating out for resiliency, the design of our structure. So it almost felt like a natural fit for us in a kind of odd way that Spinnaker came along. We just happened, when we were writing our new platform, to name it Harbor with a U. But then with Kubernetes having this nautical theme as well with the helmsman, it was almost preordained that Spinnaker was going to somehow fit in. So that was kind of serendipitous on that part. So with that, I'll open it up if anyone has any questions.
Do you guys have any issues with a lot of the firm beliefs that Spinnaker has, for example, when you first kind of taking out the project, given that you already have, it seems like a fairly expensive.
Yeah, that's an interesting question. So it's, you know, as I kind of mentioned during the panel discussion, at first when we kind of approached things and we worked with Kenzan, we tried doing things through the Spinnaker way, sort of adopting it. But at the time, as Stephen had alluded to, we are already pretty set in working with deployments. And actually through the Spinnaker Slack channel, we did a lot of questions back and forth with Lars and some of the others in the group to figure out how can we actually make this work in our existing. I wouldn't say it's been a challenge. If anything, it speaks to the flexibility offered by Spinnaker itself. But further to that, again, I think if you were to look at our pipelines, and it's a shame I can't show you one of our pipelines that we have, but it's very simple. Literally, our pipeline starts off with a GitHub check. We make sure whether or not the PR that's being presented actually has rebased off of master, and it has incorporated the latest master changes. So we leverage the GitHub webhook to do that. We always run a liquid-based stage. Then our deployment is just simply applying the Kubernetes manifest. We launch from there into the automated system tests because they only take, so on a deployment, we have different levels that we can actually do our system tests. So typically for our staging, we might do a little bit more extensive suite of tests. I think in all, we've now stubbed out about 400 different interactions as far as our API tests that can run. Even so, that takes maybe 3 to 4 minutes to operate in our staging environment. But when we're talking about production or that validation that happens, that's where those 60 tests take, at worst, 30 seconds for us to mark the deployment. We knew the limitations going in, for example, about the rolling deployments that go with the deployment model. So it wasn't a problem for us. I think, Dave, you have a question?
Yeah, I've been hearing in a couple of, both from other people we've worked with and hearing at the conference, that sometimes Spinnaker gets blamed, deployment fails, and I'm wondering if you guys have run into issues where debugging that failed app is a problem, and if that leads to perception gap with Spinnaker itself as a tool, or are your developers trained to understand how to follow through with it? And was that just a matter of local culture and you guys having a really strong documentation or buildup of documentation around how to deal with failed startups and pipelines that have failed, that sort of thing?
Yeah, actually, if anything, there hasn't been any sort of major problems from our developers in working with it. Part of it is because, if anything, going to that self-service model for the teams. So the rollout of Spinnaker itself, as far as getting teams to be able to deploy, first started off with just piloting with one of our more experienced teams and getting them to use it for their own environment. If anything, it was pre-Spinnaker. We were trying to do all of our team environments just strictly through Terraform. And one of the challenges there was that was prone to a lot of issues with the spin up of the clusters, where we were manually injecting things like some weight, like sleeps, in order just to make sure that Kubernetes came out cleanly. It actually worked to our advantage because even giving our development teams integration environments, the tendency is that they would hold on to their data sources. Oh, we're trying to get this feature out, and we need to test things. I just set up my test data just perfectly. So from a security standpoint, we started off with how we looked at our staging and production environments. And traditionally with our production environment, so using kops, we're using CoreOS. We want those clusters to live no more than 2 weeks at a given time. So we are constantly refreshing them. So we literally will have our production A cluster, and we'll have a sort of hot spare B. And we use a failover in AWS, just through DNS Route 53 group, to literally be able to fail over between the two if something goes wrong. Since we're leveraging things like etcd and kops, we don't even want to just troubleshoot it. Just kill it, send traffic to the other cluster. Taking that model and applying it then down to our development environments, telling developers, you know what, it's just easier. If you're running into some sort of issue with your environment, kill it, refresh it. And through Spinnaker, refresh takes 30 minutes to an hour to completely redeploy all the artifacts. That actually has got them where we also tell them, we will no longer support your environment if it's older than 2 weeks. We give you like a 2-week sort of leeway, like, okay, if I'm working on a more complicated sprint, it's gonna go with a couple other things, yeah, we'll give you a one-time pass that you can opt into. But then we have a process to just go ahead and kill all the environments and refresh from scratch. So if anything, the developers have become more trusting, knowing that they have such an ease to go ahead and redeploy their environments and refresh. So it's never blaming around the problems. And honestly, if we do encounter some sort of issue with the deployment, usually something that's caused on our end, outside of Spinnaker. Spinnaker's been, knock on wood, pretty rock stable.
One other caveat to what Kevin just said. If we do see a systemic problem across multiple team environments, we'll obviously look into it. We're not just going to keep tearing down the environment and doing the same thing over again. And then the other thing too is, I think most of the problems we find, which is kind of nice because we catch it before the artifact even hits staging typically, is sometimes developers haven't actually thoroughly tested the pipeline, so they've made a manifest change and they didn't really deploy it to their integration environment and go through that process, and we'll catch that because the pipeline can't be converted properly, so the evaluation of moving things into Spinnaker from the Kubernetes manifest actually through like an error, and we can go and look at it and kind of say, hey, your Kubernetes manifest isn't valid. We've had that come up multiple times. So not typically Spinnaker, typically other things that come up unrelated to it.
Hi, I was curious if you have open sourced any of the tooling that you showed today, especially with regard to some of the gaps that exist today for the cloud driver to Spinnaker integration that you were able to work around, and if so, could you please share those?
Yeah, sure, absolutely. I think as Stephen mentioned, the one tool that we have, which was the automated pipeline generation, we certainly can make that, we can talk about making that available. It was more of a stopgap, especially with the V2 integration that's underway, but I think it also echoes kind of, we had no problems with sharing how we've implemented it. I'll have to go through our legal to actually open source those particular components. I don't think we have anything proprietary, but we'll have to review it. But we can certainly share how we approached implementing it as much as possible in the interim before that. So just hit us up on the Slack channel. We're more than happy to share. But yeah, we'll definitely look into those.
I think that the hesitation to starting that process a while ago was around some of the things that kind of the direction that Spinnaker's been moving with in regards to Kubernetes. So I didn't want to release something and have people start using it and then create kind of like a mess for them when they tried to move to probably the proper way to do it in the future. And I think the V2 provider looks like it's going to be the way to go in the future. So I would say if you have like an absolute immediate need, come talk to me and I can kind of tell you what we did. But I think the effort would probably be better spent maybe helping get the V2 stuff going quicker. So that's something we're going to be looking to do, I think, internally, is dedicating more cycles to kind of helping the open source ecosystem a bit more.
Yeah. Anything that we do open source will just be on our open source page, so just github.com/Armour. We have a couple tools that we have open source, but related to specifically to Spinnaker, we haven't yet, but we're certainly open to looking at it.
In terms, I think you mentioned you guys run Kubernetes and GKE.
Yes.
Cool. Was it the decision just go straight GKE, or was there ever like a debate? So the issue is for a lot of new organizations kind of getting started, it's easy to say, well, do I use Google Cloud even though I may be in Amazon infrastructure, or do I run it myself? Did you guys ever play around with that?
Yeah, absolutely. So again, that's mainly for our team, our B2B business. They actually tried adopting or they were doing Terraform in AWS at first to do their sort of team environments. And as they were preparing their stack to move to microservices and to Kubernetes, once they did that in their team environments, they were like, you know, there's so much overhead in running Kubernetes, we just want to deal with it. So they made the decision to go to GKE. I think all from the time of actually going with the decision to go to GKE to going live in production was about 1 month for them.
Cool, thank you.
Any other questions? Well, we want to definitely thank you. That's our contact information up here, as well as our way to say thank you to the community, because we couldn't have done this, adopt Spinnaker and Kubernetes so quickly. I do have a thank you for all the attendees, and I'll probably also put it out in the Slack for the Spinnaker Summit. But I have 30% off discount codes for up to $500 one-time use at underarmour.com. Unfortunately, it is only US and Canada for those sites, so our European friends, just ping me individually. We'll work something out. But definitely want to say thank you. So thank you for being an awesome community. Thanks, Sandy.